When the following chemical equation is balanced, what is the ratio of the coefficients of nitric oxide and copper 2 nitrate? Copper plus nitric acid yields nitric oxide plus copper 2 nitrate plus water. One thing you will quickly realize if you try to balance this equation by inspection is that it is not easy to do. When this happens, check if the reaction is a redox reaction. If it is, in fact, a redox reaction, there is a couple of extra steps you need to do to facilitate the process of balancing the equation. The first step is to identify the oxidation and reduction half reactions by assigning oxidation numbers to all the elements involved in the reaction. By now, you should know how to do this. In this particular case, you should be able to identify that the oxidation number of nitrogen changes from +5 in nitric acid to +2 in nitric oxide. From +5 to +2 involves a decrease of 3. This means that nitrogen is reduced, and every time a nitric oxide molecule is formed, 3 electrons are gained by a nitrogen atom. Similarly, copper has an oxidation number of 0 in elemental copper found on the reactant side. In the copper nitrate on the product side, copper has an oxidation number of +2. In other words, the oxidation number of copper increased by 2. This means that copper is oxidized, and every time a copper nitrate is formed, 2 electrons are lost. Remember that oxidation involves an increase in oxidation number, which means a loss of electrons. In a redox reaction, any electrons lost must be gained. In other words, the product ratio must be such that the total number of electrons gained is equal to the total number of electrons lost. Let's examine the implications of the ratios given in the answer choices. In choice A, the product ratio is 1:1. If 1 nitric oxide is formed, that means a gain of 3 electrons. If 1 copper nitrate is also formed, that means a loss of 2 electrons. 3 electrons gained and 2 electrons lost. Electrons gained is not equal to the electrons lost. Choice A can't be right. How about choice B, which says that the product ratio is 1:2? 1 nitric oxide is formed means 3 electrons gained. 2 copper nitrates formed means 4 electrons lost. It's 2 electrons for every copper nitrate, so 2 times 2, or 4 electrons, are lost for 2 copper nitrates. 3 electrons gained and 4 electrons lost. Again, electrons lost is not equal to electrons gained. Choice B is wrong. How about choice C? 2 NO molecules formed times 3 electrons for every NO. That's 6 electrons gained. 1 copper nitrate formed times 2 electrons for every copper nitrate. That's 2 electrons lost. Again, electrons lost is not equal to electrons gained. Choice C is incorrect. Let's look at choice D. 2 NO molecules formed times 3 electrons for every NO. That's 6 electrons gained. 3 copper nitrates formed times 2 electrons for every copper nitrate. That's 6 electrons lost. Therefore, electrons gained equals electrons lost. Choice D is the correct answer. You can verify for yourself that choice E is wrong. So, the coefficients of NO and copper nitrate must be in a 2:3 ratio. 2 NO molecules must be produced for every 3 copper nitrates produced. We can say that every time the reduction half reaction happens twice, the oxidation half reaction must happen 3 times. In the process, 6 electrons are transferred. Now that we have established the ratio of nitric oxide to copper nitrate, we can easily balance the equation by inspection. We have established the nitric oxide to copper nitrate ratio is 2 to 3. So if we put a coefficient of 2 for NO, we must put a coefficient of 3 for copper nitrate. Note that we don't have to use 2 and 3. We can use any multiple of 2 and 3. We can multiply both by 2 and use 4 and 6. Or we can multiply both by 3 and use 6 and 9. Let's see what else we need to do if we use 2 and 3. First, we try to balance the atoms that were oxidized and reduced. We can see that a coefficient of 3 for copper on the left allows us to balance copper. We try to balance copper before nitrogen because copper appears only once on either side of the equation. Nitrogen, on the other hand, appears in 2 places on the right, in NO and copper nitrate. There are 8 nitrogen atoms shown on the right, 2 in nitric oxide, and 6 in copper nitrate. 3 times 2 equals 6. Therefore, we need to put a coefficient of 8 for nitric acid on the left in order to balance the nitrogen. At this point, we can see that we have 8 hydrogens on the left. To get 8 hydrogens on the right, we need 4 waters. 4 times 2 equals 8. We now have 8 hydrogens on both sides. Finally, we can verify that oxygen is already balanced at this point. There are 24 oxygens on the left side. 8 times 3 equals 24. And there are 24 oxygens on the right. 2 in nitric oxide, 18 in copper nitrate, and 4 in water. 2 plus 18 plus 4 equals 24.